This is the Anker 767 PowerHouse, and it's one of the most unbelievable off-grid solar generators I've ever seen. The specs on this thing are ridiculous! And today, we're going to put it to the test and see if it can justify its nearly $2,000 price point. In case it's not obvious, here's how a device like this works. It's got a giant battery inside it, and that battery charges up either by plugging it into the wall, plugging it into a solar panel, or plugging it into some other DC voltage source like the accessory port on your car. It's got a built-in true sine wave inverter, so it can output 110 volt mains power, and you could plug basically anything into this that you could plug into the wall. It's got a 12 volt accessory port, so it outputs DC, and it's got some USB charging ports. Let's run down the Anker 767 specs because they are truly unbelievable. The battery capacity is just a little bit over 2 kilowatt hours. And we're going to do a rundown test later in the video, and we're going to see just how much of that 2 kilowatt hours you can actually get out of the inverter. But based on that 2 kilowatt hour number, you could recharge about 90 typical FPV drone batteries at 22 watt hours apiece. You could run a 15 watt LED bulb for over 5 days. You could recharge a 50 watt hour laptop battery 40 times. This thing has more than enough capacity to run almost any load you could imagine, almost any load that you could run off a wall outlet for at least a few hours and maybe days at a time. The watt rating on the AC inverter on the Anker 767 is rated for 2400 watts. And it's probably not a coincidence that that's the exact same watt rating of a typical 20 amp breaker on a household circuit. 20 amps times 120 volts equals 2400 watts. So basically, anything that you could plug into the wall and run without popping the breaker, you're going to be able to plug into the Anker and run without popping its overcurrent protection. It can surge up to 3000 watts, so even if you've got a tool or other device that has a momentary surge of power, it can probably handle it. You're definitely going to want to use the retractable handle and built-in wheels when transporting the Anker 767 because it weighs almost 70 pounds. The reason I brought it out here to my wife's Scamp camper is that it's got a built-in 30 amp RV receptacle. Now, you won't actually be able to pull 30 amps from the Anker 767. Its built-in inverter only supports 2400 watts or about 20 amps. But it does mean you won't have to use one of these little adapters when you plug in your camper. Let's plug it in and try and run the AC here in my wife's Scamp off the Anker 767. You should be able to do it because we run it off a standard 20 amp mains plug all the time. Okay, plugged in and power. I hear it going. The car socket plugs on the Anker 767 output up to 10 amps, or just a little over 130 watts. And the voltage that they output is a constant, regulated 13.4 volts. And that's going to stay the same voltage even if I turn on this 500 watt work lamp. A lot of power stations just pass the voltage of the internal battery through to the car socket plugs. And what that means is that as the internal battery discharges or as you add loads to the AC side, that voltage is going to change. Not the Anker 767. It's going to stay at 13.4 volts until it's completely discharged. Now, if there's anything that Anker knows, it's USB charging. The 3 USB-C ports on the Anker 767 are rated for up to 100 watts USB PD. In other words, they can charge literally anything that charges from USB as fast as possible. That's just the highest spec. You got a MacBook that charges from USB PD, it can charge from this. The USB-A ports can only do up to 5 volts at 2.4 amps per port. So if you've got a phone or other device that's capable of fast charging, you'll want to use a USB-C cable if at all possible. One of the problems with power stations like the Anker 767 is that if you turn on the AC power and the 12-volt receptacles, then they're going to draw down some of the power, even if there's nothing plugged into them. That's referred to as parasitic drain. I turned on the AC outlets of the Anker 767 with nothing plugged in, and it showed a rundown time of just over 3 days. That means that if we just left this sitting here with nothing plugged into it, in 3 days, it'd be completely empty. Then I turned on the 12-volt outlets, and that rundown time went down by just a very, very small amount. So the 12-volt outlets don't have very much parasitic drain at all, and the inverter or the AC outlets do have a fair amount of parasitic drain. Now, Anker addresses this with their power saving mode, which you can turn on simply by pressing this button. And what power saving mode does is when the Anker 767 detects that nothing is plugged in, or when it detects that something's plugged in but it's not actually drawing any power, after I think it's about 15 minutes, it'll just go ahead and shut off that inverter. So it'll just stop powering those devices. And this is okay if, like, for example, you're trying to top off the battery on your laptop, but then once it's fully charged, okay, Anker, just go ahead and shut off. But it's no good if you've got a device that turns on and off. Like I've read that CPAP machines have this problem. The CPAP machine will turn on and off during the night, and if it turns off, and then the Anker goes, oh, cool, let's save some power, and turns off the inverter, then your CPAP machine won't come back on again. So if you want the Anker to save some of that parasitic draw by automatically shutting down when nothing's using it, you're going to turn this power saving mode on. But if you need your devices to be continually powered, then you're going to go ahead and turn that off. So that's the output side of the Anker 767. What about the input? Like, how do you charge it up? Here on the back of the unit, we've got a C13 plug for mains charging and an XT60 plug for charging from solar or DC. The unit comes with a 12-volt cable for charging from your car and a XT60 parallel adapter for charging from solar panels. And there's actually a big problem with the XT60 adapter that we're going to talk about in just a minute. The Anker power station can charge at a maximum of 1,440 watts. And that means it'll go from 0 to full charge in just under 2 hours. I was like totally blown away the first time I plugged it in and charged it up. I was like, okay, I guess I'll come back in 8 hours and it'll be fully charged. And like 2 hours later, it was done. It's ridiculous. Now, this fast charging is great for convenience, but it's not necessarily the best for the battery's health. So the Anker phone app can actually configure the charging speed, and if you know you're going to be somewhere where you don't need it to charge super fast, you can actually turn the charging speed down to as low as 200 watts to prolong the life of the battery. Speaking of the phone app, it connects via Bluetooth and gives full control of all the settings of the unit, including switching outputs on and off, and even turning the built-in light on and off. One of the most annoying things about some power stations is that they will not discharge at the same time that they're charging. And this makes no freaking sense. Like, the first time I ran into this, I could not believe it. It was so stupid. Like, I've got a freezer and it's plugged into the output of my power station while I'm camping because I'm keeping my drinks cold and my meat frozen, and then I plug it into the solar panels to top off the battery during the day and it stops outputting. Like, what am I supposed to do? Buy 2 of them and charge one up while the other one is running down? It makes no freaking sense. The Anker 767 does not have that problem. You can charge at the same time that you are discharging because of course you can, because it would be stupid if you couldn't, and I have no idea why anyone ever made a power station that worked that way. Now, a lot of people who are buying the Anker 767 are buying it with an eye towards an off-grid solar solution. And there is a quirk, a gotcha, in the specs of the Anker 767 as relates to solar charging. So the maximum charge current that the Anker 767 can take is 1,000 watts. You'll, of course, need enough solar panels and enough sunshine to hit 1,000 watts. But if you've got that, you can charge this thing from solar in just a little over 2 hours, and that's really impressive. But the problem is that the Anker's maximum voltage on its DC input is 60 volts. And in order to hit that 1,000 watt charge rate, you're going to need at least 50 volts. Stick with me here. The way that most people would get the voltage of their solar charging solution up is to put their solar panels in series. And most solar panels have an open circuit voltage of 24 volts. So 24 volts, that's not enough. I need at least 50 volts to hit 1,000 watts. You're not going to do it with typical solar panels because 24 volts times 2 is 48 volts, 24 volts times 3 is 72 volts, and that's too high of a voltage. Now, Anker does sell their own solar panels with a 60 volt open circuit voltage, and of course they'd rather you use those. But most people who are going to be buying this for an off-grid solar are going to want to save money or customize which exact panels they get. For example, the Anker panels are portable panels. What if you want rigid, hard-mounted panels? Well, you're going to have a maximum voltage of 48 volts, and you're not going to get the fastest possible charging rate, or you're going to buy Anker's 60 volt panels, and they're fine, but you probably do better. Another limitation of the Anker 767 is that you can't charge from both solar or DC and mains power at the same time. If mains power is available, the Anker will always charge from mains power and ignore any voltage that's coming in on the DC solar input. And that means that, well, the assumption is probably that most times mains power will give you all the power you could possibly want. But if you've got solar panels and you're basically getting free energy from the sun, wouldn't it be nice to also use them? If you're going to do that, you're going to need to unplug the mains power. The other weird decision that Anker made is to use XT60 plugs for their solar system. And there's nothing wrong with XT60 plugs in the right application. But what's wrong with them in this application is, first of all, they have exposed prongs. And exposed prongs are fine as long as your voltage is less than about 50 volts. Once the voltage is over 50 volts, it presents a potential shock hazard to humans. In other words, if you were to stick your finger in here and touch these prongs with 60 volts coming from a solar panel, you could get a shock. And probably this is not going to put anybody in the hospital or cause anybody to die, but it's still a weird decision. The other problem is that these are not weatherproof. So if you were going to do some kind of permanent installation, then you would not really want to use these. You'd need to find some way to keep them out of the weather. It would really have been better for Anker to use the standard MC4 connector that's used. It's weatherproof, it's enclosed, it's bigger, it's more expensive, probably, I don't know, but it's kind of weird. Oh, and by the way, if you do buy the Anker solar panels that have the 60 volt open circuit voltage, they come with XT60s too. So you're either going to be using this connector with all the risks involved, or you're going to be doing a lot of cutting and soldering. Well, if you work with solar, you're probably used to cutting and soldering. I hate the fact that with a lot of off-grid batteries, when you're not using them, they're just sitting there doing nothing, waiting for the next power outage. The Anker 767 has built-in UPS functionality. That means that if you plug it into the wall, and then plug like your computer into it, if there's a power outage, it'll cut over within 20 milliseconds and your computer should never know the difference. Let's put this UPS functionality of the Anker 767 to a test. I've got my whole workstation up there plugged into the Anker 767, and I am currently running a GPU stress test to make sure we're hitting this thing, well, not as hard as we can, but a little hard. We're pulling 500 watts. And you can see here that the Anker says we have 15.9 days of runtime left. I don't even think that number means anything, because right now we're in pass-through mode. It's just passing through power from the wall to the computer. But as soon as we unplug this, we're going to simulate a power outage. We're going to see what happens. Here we go. No interruption. Now we have gone down to just 3.6 hours of runtime at this approximate 500 watts. Let's give it a few more tests. It's plugged in. It's unplugged. It's plugged in. It's unplugged. Nah, we're good. We're just good. Oh, the screen went off there for a minute because the test was running. I thought for a minute we lost power. Nope, the test just restarted. Now, there is a limitation in the output power of the Anker 767 when you're using it as a UPS. So when it's acting as a UPS, or anytime it's plugged in and charging and outputting at the same time, it is doing what's called pass-through mode. In other words, it's not using the inverter to run down the battery and using the charger to charge up the battery at the same time. That would be silly. It's just taking the mains power in and passing it through to the load. And that means you don't wear down the battery or anything like that. But it also means that the maximum power it can output is limited by its charging circuit. In other words, when you're in pass-through mode, the 767 can only output up to 1440 watts at a time. If you go over that, you will get an overcurrent warning and it will shut down the output. And that might be a little confusing because you can pull 2400 watts from the wall And the built-in inverter is capable of outputting 2400 watts, so you would think if you plug it into the wall and then output from it, you would get 2400 watts, but you don't. You only get 1440 watts. But there's one annoying difference between the Anker 767 and a true UPS, and that's that if the Anker 767 is on battery mode and is outputting power to a load and fully discharges its battery, then when the power comes back on, the AC output stays off. With a true UPS, as soon as the power comes back, the output of the mains power will also come back and it would begin topping off its battery. This is something that basically no power stations do, and it's freaking annoying. Like, they should just Anker, release this in a software update, please. If you are on mains power and discharge the battery, when the battery turns back on, we should at least have an option in the app to have the mains power also turn back on. And it's the one real limitation that would keep somebody from using this as a truly dedicated UPS solution. Now, earlier in the video, I promised to do a rundown test of the Anker 767 and see how much of its 2 kilowatt hour rated capacity you're actually going to get when you're using it. And before we do that, let me remind you that there are links to this product down in the video description below. Those are affiliate links, and what that means is that if you're going to buy this, then click that link. And then when you buy it, I get a small commission. And a small commission on a product this expensive is actually a fair amount of money. So if you buy it, it sure would mean a lot if you use those links. It's totally up to you. It doesn't cost you anything extra or anything like that. It's just a way of saying thanks for this video. Those links are in the description below. To test the capacity and the runtime of the Anker 767, I plugged in 2 shop lights and an electric heater pulling about 1550 watts in total. The power station ran for a little over an hour, delivering just under 1.8 kilowatt hours of power. Now, getting 1.8 kilowatt hours when the specs say 2.0 kilowatt hours might seem like that's a bad thing, but there are always going to be efficiency losses when you're converting from like the DC battery to the 120 volt AC inverter output. And actually, 87% efficiency is pretty freaking good. One of the reasons it's so good is that this device has gallium nitride semiconductors in it. And I don't know from gallium nitride, but they're basically the latest and greatest anytime you're doing any kind of conversion like this. They're more efficient, 87%-ish efficient based on my measurement, and they run cooler. I also tested the rundown capacity on the 12 volt outputs using a 10 amp load, and I got just about 78% efficiency. And that's actually not that great. Like, I don't know, do they not use the gallium nitride on the 12 volt side, or is there some, I mean, it's just a voltage conversion. It shouldn't actually be more efficient than doing a AC to DC conversion. Anyway, 78% efficient here, 87% efficient here. At the time I was doing this test, the ambient temperature was 80 degrees Fahrenheit, and this unit, after an hour and 15 minutes of 1500 watts output, got up to about 115 degrees Fahrenheit. So the temperature went up, but didn't go up nearly as much as you would think, given how much freaking power it was outputting. And in case you're thinking, oh, well, surely there was just fans going crazy. No, the fans were running, but they were surprisingly quiet. Now, if you're going to spend $2,000 on a device like this, you're going to want to know that it's going to last, and that's why it's good that the Anker 767 uses lithium iron phosphate batteries. Lithium iron phosphate are really the gold standard for power stations like this today. And their advantage over lithium polymer batteries, which is what we used to use, is that lithium iron phosphate are rated for 3,000 charge cycles with 80% of their capacity remaining. Lithium polymer batteries, more like 500 charge cycles. So this is going to last a lot longer. And when you're shopping for a power station, whether you get the Anker 767 or not, you definitely want to pay more for lithium iron phosphate batteries because the additional cost is more than offset by the increased lifespan of the device. In addition, lithium iron phosphate batteries are much more stable than lithium polymer. You can literally, I'm not going to do this, but you can literally just like stab them with a screwdriver, puncture them, and they don't light on fire and burn your house down like lithium polymer would. Speaking of longevity, the Anker has a 5-year warranty, and it has a 5-year warranty from an actual consumer goods company whose name you recognize, and not some fly-by-night company you've never heard of who might be here tomorrow or might not. Anker has a customer support line where an actual human will answer your call if you call them. And this unit's even supposed to be drop safe. Like, I've seen other reviewers who actually dropped it a few times to see if it broke, and I couldn't bring myself to do that, but it's even supposed to be drop safe, so hopefully it'll last. Now, I was lucky enough to have this unit sent to me by Anker, but if you're spending your own money, then you're going to want to be sure that you're getting the best value for your money. So I did a little comparison shopping to try to see what else has similar specs and capabilities to the Anker 767 at a lower price point. And the closest I could find was the Oukitel P2001. The Oukitel costs just $1,000 at the time I'm recording this. Its specs are pretty close to the Anker's. It only has 2 kilowatts of output instead of 2.4 kilowatts, and it charges a little slower than the Anker. The Oukitel is also not expandable. We didn't even mention this in the review, but the Anker 767 can have an additional 2040 kilowatt hour battery pack that basically sits on top of it. There's a great big plug in the back that plugs into it, and it just doubles the capacity of the 767. The Oukitel doesn't do that. In addition, the Oukitel doesn't have a phone app, and it doesn't have the RV plug, but you could just use an adapter. But frankly, the reason I think that most people might shy away from something like the Oukitel is that I don't know who the hell Oukitel is. Like, sorry, Oukitel, if you're like some super established company in China and I've just never heard of you, but also it's $1,000 cheaper than this, and that $1,000 has to have come from somewhere. And so I would kind of have some hesitation wondering where they had cut corners to save that money. Nevertheless, for literally half the price and nearly the very similar specs, I think a lot of people would maybe lean towards the Oukitel over the Anker. Whichever way you decide to go, please use the affiliate links down in the video description. It sure does mean a lot, especially on items as expensive as this. I'll put links to the Anker 767, and what the hell, I'll put links to the Oukitel too. You do your own research and you decide that's for you. I'm happy that I turned you on to it. If you are interested in field charging solutions for FPV drones, I'm going to put a card on screen to a video that I did showing some. This is really too big and heavy for most people to consider it a good field charging solution. There are some smaller and lighter ones, including marine batteries, gasoline generators, and gasoline generators lighter than this? I'm going to put a card on screen running down some other field charging solutions, and I think you might be interested in it. I'll see you there.